Good morning, everyone. Welcome back. In today's video, we are going to discuss about F1 score, F1 score, and map. F1 score and the map are metrics. Metrics for evaluating the performance of an AI model. Last time, we discussed about the confusion matrix. In the confusion matrix, the ground truth is compared to the prediction of a model This is the ground truth. Positive means the object is identified. Negative means the object is not identified. On the side of the ground truth means what a supervisor like us engineers, what we can see, what we can identify with our eyes. There is also the other side of prediction, where what a model sees, what a model can detect and predict. That's positive, what a model sees. That's negative, what a model fails to see or detect. If I can see as engineer an object and a model can see it too, that means that model is doing well, and that's true positive. That's a true positive, or TP. But if I see an object or the image, but the model can't see it, can't detect it, that means this is false negative. But let's say I don't see an object on the image. model sees it. That's weird. And that's false positive. Or let's say I don't see an object and the model doesn't see it. I cannot see an object and the model doesn't see it too. That's good. That's great. That's a true negative. Of course, we don't have a single negative. If it's a model, we'll have mostly a lot of true positives, a lot of false negatives. F N. This is F P. This is T N. Okay. Most of, as I was saying, in most cases, if you are lucky enough, you can have no false positive and no false negative. Of course, we'll have a lot of true positives and true negatives. From the confusion matrix, we can deduce precision. The precision is calculated by taking true positives and dividing by the sum of true positives and false positives. And recall is calculated by taking the number of true positives and dividing by the sum of true positives plus false negatives. That was it. That was what we discussed last time. Today, let's move to other important metrics. F1, F1 score, and mean average precision. F1 score is provided by the formula, or is calculated from the following formula: 2 × This is known as harmonic mean. Where T is precision, R is recall. As for map or mean average precision, its formula is 1 over n summation sign I from 1 to n average precision I, index I. Where n is the total number of classes, total number of classes and I is a specific class in the dataset. I is a specific class in the dataset. In our case of ANPR, a class like RAC 6 9 7 T. These are the types of classes we have in ANPR. Our classes are number plates. Let's now go a little bit in details on map. In map, or mean average precision, these are the steps we follow to calculate map. The first step, the model computes the AP for detecting and correctly identifying each specific nameplate or specific class. The model, in our case, YOLO version 5, computes the average precision for detecting and correctly identifying each specific class, each specific class. In our project ANPR, the model we are referring to is YOLO version 5, and a specific class we are talking about is a specific number plate, car number plate, like RAC, something like RAC 697T. That's the step number one. The model is going to compute the average precision for detecting and correctly identifying each specific class. Then step number two. Once the average precision values for all number plate classes are computed, they are averaged. So at the completion of step one, we have APs, means average precision for different classes or different specific classes. And then in the step number two, once the average precision or average precisions, APs, for all nameplate classes are computed they will be averaged. They are averaged. What does this mean? What does this mean? means map will be calculated as the average of all specific APs or average precisions. That's 1 over n, where n is the total number of classes, then summation from a specific class I equals to 1 to the total number of classes average precisions. As you remember, n again is total number of unique numplets. In our case, in the case of ANPR, in our data set, and I, of course, is a specific class in our data set. Okay. Let's make some calculations for a better understanding. Let's say we are given this table. Let's say we are given a table. Let's say we have a data set with 3 classes. Let's say we are given a data set with 3 classes. The data set being the class number 1, say the first class is, of course, a numplet RAC697T. Another class is RAD710E. RAH213T, and let's say the average precision was given by a model during the evaluation. let's say for the first class, AP is 0.95, another class is 0.85, another class is 0. From these values, we can calculate map as follows. First of all, what's n? N is the total number of classes. We have here 3 classes. So in our formula, we have 1/3. Then we're going to sum AP. Going to sum 0.95 plus 0.85, 0.80, and this is going to be 0. As you can see, 0.90 or 9, or if we turn it into percentages, that's going to be 90%. That was all for today. In the next video, I'll focus on AP. We'll dive deep into how the model calculates AP, average precision. I hope you enjoyed today's session. See you in the next video. Bye.